Welcome back, welcome back. We're continuing on with the 2011 Cimc paper. Why don't we just dive right in? We're doing question number 3, so let's take a look. It's about a girl named Ophelia. So Ophelia is paid $51 for the first week of work at her part-time job, her part-time summer job. For each week after the first, she's paid $100. How many weeks in total does she have to work for her average weekly pay to be 93? So her average weekly pay, that'll be the total amount of pay she's received overall divided by the number of weeks. So we're asked how many weeks in total does she have to work? Okay. So that sounds as good a place as any to start by labeling a variable. So we'll call the number of weeks she worked W, capital W specifically. All right. So we know that $93 is the same as her total pay, all the pay she's received, divided by W. Okay? So if we knew the total pay as an exact value, we could then rearrange this equation and figure out what W would be. So let's think. What might her total pay be? Well, we know her total pay is an expression something like this. Total pay, she got $51 the first week. That's what the question told us. And then every week after, she got $100. Every week after the first. Okay, so to figure out her total pay, we need to know how many weeks after the first week Ophelia worked. Well, we already have an expression. Capital W is the number of weeks Ophelia has worked. So every week after the first, so that's really just W minus 1. Right? She works 1 week. In total, she works W weeks. So how many weeks after the first week has she worked? W minus 1. Total number of work weeks minus that first week. Okay. So now, total pay is 51 plus 100 times that number of weeks after the first week, so times W minus 1. So we can plug this expression of total pay back into our first formula up here, the one equating $93 as the average pay she got per week. Okay. So we know that 93 is total pay, but we have an expression for the total pay. Divided by the total number of weeks she worked, which is capital W. So 93 equals 51 plus 100 W minus 1 over W. So now we can rearrange and try and solve and get an equation just in W. So 93W, we multiply by W to get rid of the W on the bottom. is 51 plus 100 times W minus 1. Well, I don't like this expression over here. I'd like to get something just in terms of W by itself. So 51 plus, and we'll multiply this 100 through. So 100W, 100 times W, and then 100 times negative 1 minus 100. Okay. Well, I have this 51 here. I have this negative 100 here. I can probably equate the two. Or, sorry, not equate the two, cancel these guys out. So 51 minus 100 is going to be negative 49. I can do that with a calculator if I need to. So now I see 93W is equal to negative 49 plus 100W. Right? So what I want to do is I want to get all my numbers on one side and just isolate W by himself on the other side. Okay. Well, I don't like this negative 49. I'd like him to be a positive. I'd like him on the left-hand side. So I can rearrange my equation thusly. Add 49 down to the left side to cancel it out on the right side. So I have 100W over here, 93W. I could subtract 93W on both sides. $100W minus 93W. You can factor out the W. 100 minus 93, that's 7. So 7W. Now we don't quite have our W isolated just yet. We have 49 is equal to 7W. To isolate that W by himself, we need to cancel out this multiplies by 7. So we divide both sides by 7. So W is equal to 7. So we would write that in the box, or if we wanted to give a little bit of explanation as we've been doing so, make a little therefore statement, we could say we can say Ophelia worked a total of 7 weeks. Okay? We put 7 in the box, we move on to question number 4. That's one way we could do it. If we had our calculators handy, we could do it another way. Okay? Okay? We could rearrange the original equation and say the total pay is 93 times W. So W, being an integer, means that 93 divides total pay. Or total pay is a multiple of 93. Okay? We also know that total pay is 51 plus 100 W minus 1. So the last 2 digits of total pay. So using our calculator, we know the last 2 digits of total pay are going to be 51. We can just look for multiples of 93 ending in 51. And there's a way we can just plop that on with our calculator. We get our calculator handy. We do 93 plus 93. So that's 2 times 93 plus 93. We keep adding. And pretty soon we come up with 651. Okay. That's a multiple of 93. So that's 6 hundreds plus 51. So that would suggest that W would be 7. And if we divide by 93, we note that the answer is indeed 7. That's another way you could have attacked the problem. It's not as exact, but it's probably a little faster if you can make that observation. The way we did it was fine with algebra, but this is a nice other way to do it if you have your calculator handy, if you like your calculator more than you like manipulating algebra. So there's 2 different ways we can handle that question. So in total, Ophelia worked 7 weeks. Just be careful with this one. It would be a good question to write out a little bit of explanation, because it's possible you could have set up the equation wrong or jumped the gun at the end and said, 6 work weeks rather than 7. 6, I imagine, is an answer they got a lot of times on this question rather than the actual answer of 7 work weeks. But that concludes question number 3. In the next video, we're going to move on to question number 4.